This animation shows a particle moving in a circular path. The red arrow is the tangential velocity. The green arrow is the radial or centripetal acceleration pointing towards the center. As the particle moves, the tangential velocity is always perpendicular to the radius, while the radial acceleration always points toward the center. Let's understand how the arc length and velocity relate in circular motion. The arc length s is equal to r times theta. Differentiating s with respect to time gives ds by dt equals r times d theta by dt. This means that the linear velocity along the arc is proportional to the angular velocity. Finally, we write v equals r omega, linking the linear and angular velocities. A particle moves along a circular path. At point A, it has a tangential velocity. As it moves to point B, the direction of velocity changes. The red arrow represents the change in velocity, delta v, which points towards the center as the angle becomes smaller.